Welcome. This video will be about the remainder theorem for polynomial functions. The remainder theorem states if a number c is substituted for x in the polynomial function, then the result f of c is the remainder that would be obtained by dividing the function by x minus c. What remainder would we get if the function f of x is equal to x to the third minus 2x squared minus 5x plus 6 was divided by x plus 2 and x plus 1. For the remainder theorem to work, we would need to take the x plus 2 and set it equal to 0. Then we would need to evaluate the function f of x at negative 2. Since the answer of f of negative 2 is 0, that means the remainder would be 0, and it means that x plus 2 would divide evenly into the given function. Now let's take a look at what kind of remainder we would get if we take the function and divide it by x plus 1. What we need to do is take x plus 1 and set it equal to 0, and we would get x is equal to negative 1, and take negative 1 and plug it into the function. Notice that the remainder we got was 8. Therefore, the x plus 1 would not go into the function evenly. Go ahead and pause and try and see what remainder would we get if we take the same function as before and divide it by x minus 1, x minus 3, and x minus 5. For x minus 1, we would need to set x minus 1 equal to 0, and we would evaluate the function at positive 1. And that would give me a remainder of 0, so x minus 1 would be a divisor of the given function. Now let's try x minus 3. Set it equal to 0, and we want to evaluate the function at positive 3. Again, we get an answer of 0. That means that x minus 3 will go into the given function evenly. And let's see if x minus 5 will go into the given function. We're going to evaluate the function as at f of 5. And we get a remainder of 56, so x minus 5 would not go into the given function evenly. Using the remainder theorem, let's find the remainder for the following function. F of x is equal to x to the fourth plus x to the second minus 20. And we're going to evaluate it when x is negative 2, 1, and positive 2. Since we already know what x is equal to, we're going to evaluate the function at those given points. F of negative 2 gave me a 0 remainder. So that means that x plus 2 would go into the function evenly. Let's evaluate the function at 1. Its remainder is negative 18, so that means that x minus 1 would not go into the function evenly. And let's evaluate it at positive 2. And again, 0 is the remainder for f of 2, so that means that the expression x minus 2 would go into the function evenly. Go ahead and pause and try to use the remainder theorem to find the remainder for the given function for when x is negative 2 and positive 4. Let's evaluate the function at negative 2. My remainder for f of negative 2 is 19, so 19 would be the remainder, so that means that the quantity x plus 2 would not go into the function evenly. And let's evaluate the function at positive 4. And that would give me a remainder of 21 for f of 4. And that would mean that x minus 4 would not go into the function evenly.